We designed a novel experimental protocol aiming to induce mind-wandering and thus understand the stages of the process and the neural activity correlated with them. Under three different visual conditions: baseline, two-dimensional, and three-dimensional visual stimulation, participants had to perform an active auditory oddball task. 25 participants, 11 male and 14 female, aged from 18 to 45, attended the experiment. During the experiment, participants were asked to fixate their eyes on the red cross in the visual stimuli and respond to the auditory task by pressing spacebar. The order of the sessions was randomized and each participant had a 2 to 5 minutes break between each session. Followed by that, a semi-structured interview was conducted with each participant for obtaining more detailed reflections about the experience of mind-wandering during the different conditions. Besides, 4 different questionnaires were administered: immersive tendency questionnaire, mind-wandering questionnaire, mood questionnaire, and family history of mental illness screening questionnaire. Of electrophysiological data was performed using 2 toolboxes based on MATLAB, EEG Lab, and Brainstorm. We looked at segments of the brain signal associated with the exposure to baseline and oddball auditory stimuli. Event-related responses were compared across the 3 experimental conditions. A Hilbert transform was performed in order to analyze the time frequency and to obtain information about the power and amplitude of delta, theta, alpha, and beta frequency bands. The qualitative analysis of our experiment included transcribing the data from the semi-structured interviews and performing thematic analysis. Semi-structured interviews aimed to thematically analyze the subjective experience of participants in terms of emotional states, attentional shifts, vocal experience, thoughts during ongoing tasks, and perceptual disturbance. In order to understand the link between individuals' mind-wandering and immersive tendencies and task performance, and the difference between subjects with and without family mental illness history, we ran different types of tests. Our results revealed highest mind-wandering tendencies under the 3D condition indexed by both EEG data and qualitative data. The visual stimuli induced a negative deflection of the participant's mood. Both EEG data and results from mind-wandering questionnaire suggest subjects with family history of mental illness experienced a higher frequency of mind-wandering. Interestingly, we found that participants experienced the highest mind-wandering tendencies under the 3D condition, which was also associated with faster responses to the oddball auditory stimuli. This indicates a transition between attentional states. Despite the studies done on this topic, none of them has looked into the transition of states that is characteristic of mind-wandering. Moreover, there is no established paradigm to studying this process. Results from the present experiment have the potential of explaining the complex transition between mental states, which becomes abnormal under certain conditions. Thus, focusing on the moments of transition between states can yield valuable information about these conditions. Through inducing mind-wandering with an immersive environment like the virtual reality, we can investigate individuals' propensities to not only mind-wander, but also transition to a state of awareness where people bring their attention back to the external environment. In this case, we can speculate that slower responses to oddball stimuli under 3D stimulation can signal abnormalities in the awareness process. This can further be investigated, aiding the discovery of any abnormalities of cognitive processing that may have caused the attenuated responses.